So now that we're armed with our little formula, you can either think of it as my radian angle is the arc length divided by r, or you can rewrite that and say my arc length is the radius times my angle measured in radians. We have a formula. And again, I'm going to kind of test to make sure we're basically you guys are following my directions. I do have a feeling some of you aren't watching the videos, so I'm going to make a little bit of a class rule here, because I think a lot of you are just turning your calculators and doing a bunch of number crunching, which is fine, all right? But again, what I'd like to do is let's try to be exact as we can, and with fractional measures. This is going to do two things. One, tell me you're watching the videos and following my directions. Or two, it's going to really help us with some fraction work. That's one skill. As I've watched you guys over the last 4 weeks, our fraction work for some of us is a little weak. So, so my intention is twofold, right? One, to make sure you're watching the videos. Two, to help you out with that fraction work. So let's try to make it exact. And how about the rule will be this, right? If we have some nice integers or things that are 1 decimal, those are very easy to change to fractions and just use fraction work. But when I have 3 or 2 crazy decimals, we will turn to technology and use some 4 decimal accuracy with that. So you'll see a little bit of a blend. But there's our class rule. So if you're dealing with some nice integers, or you're dealing with something that's relatively easy to convert to a fraction, a tenth is one of those. Let's go ahead and work in fraction mode and give our answers in exact fraction answers, as opposed to if you have more than 1 decimal, then we'll go ahead and we'll use the calculator for that. So with that being said, what we're going to do in part 1 is we're going to find the arc length along the edge of a circle with the given information. So our first circle has a radius of 8 and an angle of pi over 3, which is in radians. So what's our arc length? Well, it's r times theta, and so our arc length in this case would be 8 times pi over 3. And so our answer that I would love to see from you guys, right, on a quiz is 8 pi over 3. I'm fully aware that you can put that in your calculator and do some number crunching, okay? But again, let's get better at fraction work, okay? So and make sure you're watching. So the next one, again, we're given the radius and we're given theta in radian mode. So basically we have s our theta. Of course, 10.5 in terms of a fraction, that's 105 over 10. All right, that one singular decimal. So 105 over 10, and of course we're multiplying it to our, we're multiplying that to our radian. And so there's our radius in fraction, and there's our theta in terms of its fraction. And now let's do some reduction. We're looking around here. I know this 5 goes into itself once and there twice. I don't know 6, but I do know, I think we can divide this by 3, that goes in twice. And if we divide 3 into this, we get 35, I believe. All right, and so when all said and done, we have 35 pi all over 4. All right, and so that would be the arc length of a circle of 10.5 feet radius, and if we swept out 5 pi over 6. And I guess I should be drawing some pictures, right? So if we had a circle of radius 8, and we went pi over 3, right, that's roughly 60 degrees. Right, so that measurement of the arc length is 8 pi over 3. For this one, we have a circle that's 10.5. 5 pi over 6 is definitely taking me way over here to the second quadrant, right? And so this arc length that we found, there's the 5 pi over 6, a 30-degree reference if you would. And so the arc length along that edge is 35 pi over 4. Again, a nice exact answer, class rule. Given integers or single decimal, let's go use some fraction work. As opposed to down here, we have more than 1 decimal. So my radius is, again, my formula is s equals r theta. In this case, we have 1.234, and we're going to multiply that by pi over 2. Okay, so again, my TI calculator is a little under the radar, so I believe, all right, this can handle that. So how about I go ahead and calculate with this calculator here. It's my Kindle. We'll take a look at pi divided by 2 first, and then we're going to multiply that number by 1.234. 1.234. And so when I press equals, I get 1,938 looks like 3627. So S is estimated to be 193836, 36 and 27, and this would be in meters, right? By the way, I think this was inches, and this would be in feet. So again, picture-wise, we have a circle, right? We sweep out 90-degree angle, right? The area of this circle of 1.234 meters, or excuse me, the arc length along that is, I think I actually messed something up. Let me do that. It doesn't seem right. So why don't we go pi divided by 2? That equals that. And then when I multiply it by 1.234, yeah, I thought that's a little too big. So 1 point looks like 9384. So even I need to adjust my calculator. So this is estimated to be 1.9384 meters, and that seems to make a little more sense. Okay, so radius is this. If we go a quarter rotation or 90-degree rotation, we've just measured out the arc length, 1.9384, rounded off to 4 decimals. Again, this is 2 decimals, so we got our formula, S equals our theta. So S equals 22.89, and we're multiplying that by 7 pi over 4. So again, picture-wise, this is a 45-degree reference all the way over here. So there's our theta, and we're basically trying to figure out how much of that arc length we have for a 22.89 centimeters. And so again, I'll use my calculator here because that's, a couple decimals. So how about I do this first? I got 7 times pi, and we're dividing that by 4, so that equals that value, and then we're now multiplying that to 22.89, and that equals 125. So this is estimated to be 125.8443, and this would be centimeters. Okay, so nice direct application of this. We're 7 minutes into that application. And again, just let me remind you, so I know you're watching my videos, any nice integers or anything with a single digit, let's go ahead and use nice fractions, get used to working with fractions and practice that skill. Anything more than a couple of decimals, let's go ahead and turn to our calculator. Okay? Obviously, the homework on My Math Lab will be different. They'll ask you for that, but you should be prepared for quizzes to do things like that. All right? So that way I know you're listening, and I also will help you practice those very, very important fraction skills that will be important for us later in the semester. We're 8 minutes into this, so how about I finish these next 4 problems in another video.